Okay, so good day, grade 8 math science students. Okay, so for this lesson, for our module 7, we have here our 7th module, trapezoid and midline theorems. So we're not just going to discuss trapezoids here, we're also going to discuss more about triangles and its foundation to, or its relationship to, midline theorems. Okay, so we have here trapezoids in real life. Okay, so you can see here, guys, we have here a roof. Okay, so the shape of a roof of a mostly found in subdivision roof. Okay, and also when you look outside, you're going to see shapes of roofs that has trapezoid on them. Okay, and also the shape of a popcorn. Okay, so the popcorn container or the popcorn box. Okay, so it has faces that are shaped like trapezoids. Okay, so this popcorn box has 4 trapezoidal faces for its cover. And then we have the roofs. Okay, so more roofs during the Japanese era. So these are the roofs during the Taisho period, okay, or the early Japan period in the 1900s or the 1910 to 1920. Okay, so there you go. So you have those kinds of roofs. Okay, and this is a much clearer picture. And also, if you look at here very nicely, we have a trapezoid. Okay, and also in modern buildings, we have these weird looking trapezoids. So this one is an isosceles trapezoid. So its legs are congruent. And then we have here a, what do you call this? We have here a normal trapezoid or a trapezium if it's from UK, if you're going to use a UK term. So there you go. So these two sides are not congruent to each other. And also on windows, if you look closely, you're going to find trapezoids there. Okay, there you go. So again, guys, doing a short review of trapezoids and trapezium. Okay, so we have here the terminology for US, USA, and also for the Philippines. Here in our country, we're using the word trapezoid to describe any quadrilateral that has one pair of parallel sides. But for UK countries, okay, or UK colonized that are still using UK English. Okay, so they use the word trapezium. But essentially, they're the same. It's a trapezoid. A trapezoid is any quadrilateral. It's a quadrilateral that has one pair of parallel sides or parallel bases. So for here, we have here line segment UA is parallel to line segment QD. Okay. And then we have here, each lower base angle is supplementary to the upper base angle on the same side. So we can have here that these two, angle U plus angle Q, okay, is equal to 180 degrees. Okay. And then we have the other type of trapezoid. Okay, so this trapezoid is the isosceles trapezoid. It has more properties as compared to the regular trapezoid with just a pair of parallel sides. So an isosceles trapezoid has bases that are parallel. Okay, so UA is parallel to QD. Its legs, okay, the legs of the trapezoid are congruent. So we have your QU. Okay, line segment QU is congruent to line segment AD. And also the lower base angles are congruent. So angle Q is congruent to angle D. And the upper base angles are congruent. So angle U is congruent to angle A. And the diagonals themselves are also congruent. UD is congruent to QA. Okay, and then when the diagonals intersect, the adjacent segments on the diagonals are congruent. So what does that mean? So let's say, for example, we have here point E, okay, at the middle. Okay, so that means that UE, okay, UE is congruent to AE. Okay, and it also means that QE, okay, so let's put 3 markings on that, is congruent to ED. Okay, so that's what number 6 means. And number 7, the opposite angles are supplementary. So that means angle U plus angle D, their measurement is equal to 180 degrees. Okay, so let's jump right ahead with the first proof. So we want to prove that if a quadrilateral with one set of parallel sides is an isosceles trapezoid, then its legs are congruent. So essentially, we want to prove that this line segment GA is congruent to line segment RD. So what can be our first statement here? So we can write here given that, okay, isosceles trapezoid GARD. Okay, so isosceles trapezoid GARD, and the reason is simply given. Okay, so we can write that as given. And our second statement could be that since it's an isosceles trapezoid, then its base angles must be congruent. So we can write here for number 2, angles, okay, angles G and D are congruent. So they're the same. So the reason for that, the main reason for that for number 2 is base angles of isosceles trapezoids are congruent. Okay, and then we can introduce new points here. So let's say we constructed point Y and point U. Okay, point Y and point U that are perpendicular to point A and point R. So let's write that. Okay, so let's write here. So let's write here for number 3. Okay, AY is perpendicular to GD. Okay, okay, and RU. Okay, and RU is perpendicular to GD. And the reason for that is since there can be only one point, okay, there can be only one point and one line that can be perpendicular to a given point. Okay, so we can write that. Okay, okay, so there is only one line or one point that can be perpendicular to a given point or line. Okay, so that can be our third statement right here. So what can be our fourth that could be our third reason. So what can be our fourth statement? Okay, so our fourth statement could be, okay, number 4, we can say that angles AYG, okay, angles AYG and RUD are right angles. Okay, so they're right angles. So we can say here for number 4, definition of perpendicularity. Okay, so there you go. We have here number 4. And for number 5, okay, we can say that, okay, number 5, angles AYG and RUD are congruent because through the reason of definition of right angles. Okay, then we can say here for number 7 that AY is congruent to RU. Okay, because, okay, we can write here their reason. Okay, because parallel lines. So since AY and RU are perpendicular to each other, therefore they are parallel. So we have here parallel lines are equidistant from each other, and we can also say that they are congruent. Okay, since they are inside an isosceles trapezoid. Okay, in between two parallel lines, and therefore we can say here for number 8. Okay, we can see here for number 8 that triangles AYG and RUD are congruent. So they're congruent. Okay, so using the number 8, using the AAS triangle congruence postulate. Okay, and then lastly, since we have seen or we have proven that the two triangles here are congruent, then their corresponding sides must be corresponding parts must be congruent. So number 9, GA is congruent to RD. Okay, and the main reason for that, number 9, is CPCTC, or the corresponding parts of congruent triangles are congruent. Okay, so there you go. And this finishes our proof. Okay, so let's try the second proof. So we want to prove that if a quadrilateral is an isosceles trapezoid, then the diagonals are congruent. So for the previous proof we have here, we proved that the legs are congruent. For this one, for the isosceles trapezoid, we want to prove that their diagonals are congruent. So we can write here for our first given that isosceles trapezoid TIGR. Okay, so that's simply a given. Okay, and what do you think, guys, can be our second statement here? Okay, for number 2, okay, we can write here angles. Okay, angles ITR and GRT are congruent. Okay, so they're congruent to each other. So how are they congruent? Because the base angles of an isosceles trapezoid are congruent. Okay, so let's try number 3. What can be our third statement here? Okay, so for number 3, we can say that TR is congruent to itself. Okay, TR is congruent to TR. Okay, so TR is congruent to TR. Okay, using the reflexive property of congruence. So the plan is, guys, we want to prove that this triangle TIR is congruent to this triangle RGT. Okay, so we've seen that TR is congruent to TR and ITR is congruent to GRT using the properties of a isosceles trapezoid and the reflexive property of congruence. Okay, so also we can write here for our statement number 4, one of the properties of an isosceles trapezoid is that it has congruent legs. Okay, so we can say here that TI is congruent to GR for our fourth statement. Okay, so for number 4, we can write there TI is congruent to GR because the legs, let's write that neatly. Okay, so legs of an isosceles trapezoid are congruent. Okay, so there you go. So we have here our statement 4 and our fourth reason. Okay, legs of an isosceles trapezoid are congruent. Okay, so we can see now, we can now see here that we have two sides that are congruent. Okay, TI or IT and GR, and also we have TR is congruent to itself, and also we have here two angles ITR and GRT that are congruent to each other. Therefore, using the using the SAS, okay, the side, the included angle, and the side, other side, we can say here for number 5 that triangles ITR and GRT are congruent to each other. Okay, number 5, okay, using the ASA, triangle congruence postulate. Okay, and since we've proven that, we can now say here on our sixth statement that TG is congruent to IR, or the diagonals of this isosceles trapezoid are congruent, or any type of isosceles trapezoid, so all of their diagonals are congruent using CPCTC, or the corresponding parts of these two congruent triangles that we have proven, ITR and GRT, okay, holds true and are congruent. And there you go. So that's the end of our second proof. Okay, so after proving some of those theorems, the other theorems you can find the proofs on the module. Okay, so we'll now move forward with mid-segment of a triangle, or the midline of a triangle. So before we tackle the midline theorem for trapezoids, we have to first tackle the midline theorem for triangles. Okay, so before doing proofs regarding medians and mid-segments of trapezoids, must first understand how the mid-segment and median of a triangle is formed. So a mid-segment is a line segment that connects the midpoints of two opposite sides. Okay, so if for example we have here this triangle, okay, that means the mid-segment connects these two opposite sides, okay, at their midpoints. Okay, so that means this is congruent to this. This is congruent to this, and this 3 marks is congruent to this 3 marks. Okay, so the mid-segment of a triangle theorem states that the mid-segment of a triangle is equal to 1/2 deferred side. So we'll see that